Okay, hi everyone. So we're gonna continue the graphing that we had started last time. So we're gonna go between negative pi and pi, and I'm just gonna center it here. So negative pi and pi right there. That means the halfway mark, I add negative pi and pi and divide by 0. I divide by 2, so that's 0. And here we have negative pi over 2, and here I have pi over 2. Now my amplitude is 1/2, and I'm graphing a sine. We know that sine starts at 0, and we're going to keep going between 0, the maximum, 0, the minimum, and the max to 0. And our maximum in this case is going to be a half, which is right there. So 0, half, 0, minus half, and 1. So what we get is a graph that looks like this. Okay? Ooh, and of course I made a mistake because I didn't see what we were doing yesterday. So this is raised up by 1 degree. That means I don't start at 0. Everything now is going to move up 1. So that means my new axis, it's no longer the x-axis, my new axis moved up 1 here. Okay? You can even make that a dashed line like this. And now it's the same exact thing. So I would start here, up a half, down to 0, down a half, back to 0. So that is what that looks like. Okay, so let's move along. All right, in the case of this one, we want to write an equation that corresponds to the following graph. So what do we need? First, we need the period, we need to know the amplitude, and we need to know if there is a phase shift or if the graph has moved up or down, and all that good stuff. So we know that the equation is y equals a. Now we can see that this starts at the axis here. It looks like, you know, it's at the center. So this is a sine bx plus c plus d. All right, so first off, let's take a look at the period. This is one peak, this is another peak. The distance here, so if this is 1 pi and this is 5 pi, the distance here is 4 pi. That means the period, which is 2 pi over b, is equal to 4 pi. That means 2 over b is equal to 4. So b is equal to 1 over 2. So that's my b. Now for the amplitude. For the amplitude, you find the center of this wave vertically. And now this distance should be the same as that distance, and that's your amplitude. So this is a distance of 1, 2, 3, 4 units. So your amplitude is 4. Now, has there been a vertical shift? Well, yes, it has, because whereas sine would have started here, now it starts here. So it's moved down 2. So d is -2. And now what about the horizontal shift? It looks like actually there is no horizontal shift because it's just moved down a little bit. So now I have everything I need. My c then is equal to 0. So I would just put this into my equation and I get y is equal to a, which is 4, b, which is a half, sine. Okay, so this is before I've had my second cup of morning coffee. Sine half x minus 2. All right, here's another one. Write a sinusoidal function with the given period and the amplitude that passes through the point. So again, the period is 4 pi. That means 2 pi over b. is equal to 4 pi, and that's what we had up there. So b is now 1/2. This is straight out of the book. So what we're going to do now is the amplitude is 2. So my equation is going to be y is equal to 2 sine half x. Now, there is just one little issue here. When we get b here, this is actually the absolute value of b equal to 1/2. So technically, b could possibly be plus or minus 1 over 2, plus or minus 1 over 2. So now we're going to check, is it 1 over 2 or is it negative 1 over 2? The way we do that is this. We plug in the point pi, and let's see if we are going to get 2 for y. So basically, this is x, this is y. We're going to let x is equal to pi, and we're going to see, is y going to equal 2? So let's just see that. Y is equal to 2 sine pi over 2. Sine of pi over 2, right? Pi over 2 is here. Y value is 1 at that point. So this is equal to 2 times 1, which is in fact equal to 2. That means we have the right value of b. So that means this is the final answer. Okay? All right, guys. So this is it. That's the homework, and I'll see you back after Thanksgiving break. Have a great Thanksgiving.